Good morning, everyone. Tuesday, May 5th, Cinco de Mayo. Um, some of you may know it's a special person's birthday today, too, but I won't mention his name. Let's take a look at this photo. Took this yesterday, and the title says, "What's that?" I took this picture just off of College Road near Jolly. It's MSU's property. I didn't jump the fence, considered it, but did not. Zoomed in on this particular tree, and we see a bunch of things up there. It's got a special name. It's unique. There used to be one near Okemos High School, but no longer there. Now, seems as though there's one here. What's it called? If you know the name of this phenomenon, if you know the name of this phenomenon, put it in the stream. You might get some extra credit or a pat on the back. Shout outs. Osborne and Bliven, 8 out of 10 on the ethanol and BTB demo form. Great job, girls. Outstanding answers, and you were really, really close to that perfect score on that, which the questions were tough. We're going to go over that. We're also going to talk about our new grading system, the Mario Kart grading system. We'll get into that. Ethanol and BTB form results, and I'm going to show you how to use Google Draw today so we can get into these molecules that we're examining. So let's get started. I was thinking, based on a couple emails that I just received about things like Skyward and Google Classroom, and I'm like, this class isn't running this way. This class is more exciting than that. Who wants to look at Skyward? We're going to use it, obviously, we have to. But realistically, we have some people out there that are performing at a high level, and they don't deserve just a proficiency standard. They deserve a Mario grading scale system. So I inquired, I asked who some of their some people that are around me and some teachers as well, who their favorite characters are from Mario, and especially Mario Kart. And so we're going to have a class vote on which Mario character would represent the advanced level of proficiency, kind of like what our 2 shout-out award winners today would be. We're also going to have emerging people that are really close. We had a lot of emerging people on the quiz yesterday. A lot of people got 7 out of 10, quite a few. Not a lot, but plenty did. And what about basic? You know, you're just getting by, but hey, we need to let you know where you're at. So we're going to have a vote on a form. You vote, and I'll have a list of characters. You vote for your favorite character and who you think should be the advanced Bio A Mario character. Ethanol and BTB demo results. Here we go. Here are the ones that we didn't get many correct responses. And I know that when you select choices, and not just A, B, C, D, but you have to actually pick maybe more than one, our percentages do go down with that. So when you check boxes, this particular question had 2 correct answers, and some people had 1, some people had maybe none, but not many people had both. So we only had 6 out of 37 that were dead on with this. How do you prove that matter changed in the demonstration? Well, the BTB changed color. We know BTB changes color for good reasons. BTB changes color because we know that is an indicator that a molecule known as CO2 is present. We know that CO2 is not in the beginning of the demonstration. Somehow CO2 is formed. Again, remember, we have the flame, we have our Petri dish over here, and that CO2 is given off. So that indicates that a chemical change occurred and that BTB is responsible for that. A lot of people, I was happy to see, and this is actually even more popular, that the water forming on the inside of the aquarium. Yes, a lot of people don't realize that when you burn something, water vapor is formed. Now, some of you that have had chemistry know that the vapor forms because of condensation as it cools, but that is a key thing too. So we also know that water is possibly coming out of this as well, which indicates, again, another change that's occurring. Measuring mass, it does not deal with change, but measuring mass is dealing with movement, okay, of our materials. And same thing with the BTB. So things moving from one place to another, we're using mass for that. So hopefully that cleared things up on how we proved that matter changed. You had to have both of these for the correct answer there. All right, so we get into the second part, the second question here that a lot of people missed, and we had only 8 out of 37 correct on this one. And how would you prove that matter did move? And we just said when we have the mass of the ethanol before and after, we know that the ethanol drops. So the mass of it drops. So we know that matter is moving. So we have some matter that's moving out of the ethanol. So again, if I draw that petri dish here, and we know that some of the matter is moving out, therefore this mass drops in the ethanol, which I'll abbreviate ETH. We also know that the BTB actually, which was kind of cool, it doesn't go up a lot. And that's another question. Why doesn't it? Why aren't the two things equal? That's something to think about. There is some deeper understanding there if you know why the BTB doesn't increase the same amount as what the ethanol loses. There's some good explanations for that, and feel free to dive into that if you want to. So that's a key thing there. But the mass does go up in the BTB. So the BTB, which is in a different beaker, which is changing color, okay, this BTB is going to increase in mass, and that's going to be another key factor there too, which allows that to occur. So answer to how it moved, deal with mass. If you know that, you're going to be fine if you see this question again. All right, and finally, another question, 5 out of 37, a fairly low amount. And then just because you had to have 3 of these to get it correct, the forms of energy which are demonstrated in this particular demonstration. The energy that you see in this situation, one of which you don't see, the very first form of energy involved in the demonstration is the chemical energy, okay? And remember that the chemical energy would be in the ethanol. So ethanol, we know, contains CC and CH bonds, and so that's going to be the chemical energy there. You don't know that. Water doesn't have that, but we know that ethanol does. There's something about it that makes it have that potential energy. Some people use that term too, which I like. But remember, we are going to be calling that chemical energy. When it burns, obviously, so when we burn it, we get our flame, we're producing then that chemical energy gets converted into light and heat, two different forms of energy that are converted. We had 2 people that had mechanical. If we were turning something, maybe like a steam engine or something like that, you could say some energy was converted into that, but we didn't do any of that. So chemical converted into light and heat is how you should have gone about that. Surprised at the low numbers for light. I'm not sure why, but do remember when you burn something, those are that form of energy is what's being converted. All right, we're going to go to then next how we're going to use Google Draw. So I'm going to clean our screen off here and get back to that. And I'm going to demonstrate to you an assignment you're going to work on today, which is you're going to draw some of the molecules that are involved in the ethanol BTB demo using Google Draw. I'm going to show how you can work with that. So what I have here is I have a template that you're going to see today when you open this up as your assignment. You're going to see actually the rules for everything, and I just want to go over these briefly with you. You're going to be building ethanol, and I give you the formula C2H5OH. Notice that there's a hydrogen here, but it's not here. That can help you design that molecule. It's kind of a special way to help people understand it in terms of drawing it. And basically what you're drawing is what are ball and stick models. Typically in the classroom, you would be putting these together with actual model kits that we have. But for right now, you're going to use Google Draw, which works just as good. Carbon dioxide is another molecule you're going to build, oxygen, and water. But there's some new things. You could obviously Google these things. You don't need to. You can follow these rules and you're going to have a deeper understanding. Here are some rules that you have to understand. Carbon atoms have 4 bonds, and bonds can be single, double, or triple. So that means a carbon atom has to have 4 connectors to it. And you can either have 2 and 2, 1 and 3, kind of a combination of things, but typically carbon atoms have single bonds around it, and they'll have 4 of them. I'm going to demonstrate that. Oxygen atoms will always have 2 bonds, and it can either be single or double, depending on what it's connected to. Hydrogen atoms can only have 1 bond, and they're very small atoms, and that's what we have there. Now, new thing that we're going to put into this, typically in the classroom, we use twist ties to wrap around our high energy bonds. Instead, you're going to use a yellow or gold colored stick to represent the carbon-carbon and carbon-hydrogen bonds that are high in energy. So I'm going to demonstrate on how to build methane. So basically, I'm going to use my toolbox up here. I'm going to click on this, right-hand click, copy it, and paste it. So I'm going to then drag that down here, position it, and there I have my carbon atom. All right, well, it says carbon atoms have 4 bonds. So I'm going to grab a bond, copy it, and I'm going to need 4 of these things. So we're going to take 4 of those, and we're going to stick those to the atom here. So we're grabbing our different, and you can change up the sizes of these things if you need to. This one needs to be spun around so it's vertical. And there we go. Shorten these up a little bit. And we got one more. Oh, wait a minute. Carbon and hydrogen? Hold on. These aren't even the right bonds. So as you can see here, these would not be low energy bonds because it's carbon and hydrogen. So I grabbed the wrong one. So as you can see here, pretty simple, copy and paste, and I can build this molecule as such. I can take my hydrogen, and there we go. And then I would just have to continue doing that all the way around by copying and pasting the different bonds. I'm going to need 4 of these things. And we're going to then, I would complete that. So I would have 4 hydrogen atoms and 4 gold bonds around them to represent that high energy. So all you got to do is you make your part, the assignment, you're going to have these 4. There's going to be some boxes for you. There'll be an example drawing. You just have to complete that and submit that assignment for today. And also make sure you vote on your favorite Mario character, who you think should be the advanced one. And then we will see you all on Wednesday, where we will break down what's going on molecularly with the ethanol to finish things up. Have a great day, everyone. Thank you.